Okay, we're going to talk about another example application that our group has done. This is an effort led by Gary O'Brien and Wally McFarland for the Bureau of Land Management on the Lower White River. So this is just a white paper report, geomorphic assessment of the Lower White River. This is based off of, this is using river styles, and so unlike the other examples, I'm not going to go through all the results. I'm just going to highlight a couple of key differences that Gary employed in the analysis here that I think are helpful. One reason I want to show you this is for the class. A bunch of you do work in the Colorado Basin, and so this is the portion of the Lower White that's spanning the Colorado-Utah border here. But the other thing I want to show you is just some of the kind of taking some of the analysis to the next level with these stack profile plots, and so and that river styles can be done for the entire drainage basin, or it can be done for just a main stem. And so this is an example where it's just done for a main stem. And so for this main stem, Gary pulled off these by reach, these stacked profile plots. And so at the bottom here, this is the distance from the confluence. Okay, so this would be down at the confluence with the Green River. And then up at the top of the reach here, in gray is the focus for this particular study, which happens to be owned by BLM. And then we're getting onto tribal land downstream of that. And what you have here at the bottom, these are the different river styles. So these are the sort of key for those river styles. And so this is confinement, is degree of confinement for these different reaches, right? So this is less than 10%. So there's a big, obviously a big area where it's fairly unconfined. And then similarly up here, there's some pockets, some sections that aren't. Then we're in these middle reaches that are largely partly confined, and then there's a few little short segments of confined. And so this is then showing then, as you're moving through all these reaches, geomorphic condition, channel sinuosity, and then channel confinement. So that's just kind of convenient way of looking at this. And one of the things that Gary did here is there's another paper that we're not reviewing that Gary and we published on using what we call the confinement tool to map out the confining margins and then to actually calculate the degree of confinement. And so this tool was applied here, but then manually Gary went through and confirmed all of the confining margins. And the significance of this and what we've just been through is, remember that the valley setting is the entry point, and the valley setting is discriminated based off of confinement, the proportion of the length of channel where it's up against a confining margin on either side. And so this is just showing how much of this is either unconfined, partly confined in either plan form or margin controlled, and then in confined segments. And so this is the same information that you're seeing reflected right here, right? But then this is just mapped out across that. The other thing that and then I guess the point to make here is that the river styles fall quite nicely out of that, right? If you go back to the procedural tree, that's the main sort of breaking point and discrimination point. And then there are further breakpoints underneath the tree or branches really for where you get into your different reach types. But that gets you, that gets you more than 2/3 of the way there. So what Gary did was kind of take that a step further, and then in the valley bottom, and so this is actually an output of our valley bottom tool, and so the red and the sort of olive combined are the areas preliminarily sort of identified as potential valley bottom, and then the red are areas that he identified as actually these are valley features, but not valley bottom features. And so he found there's a bunch of coalesced fans here from all these kind of unstable slopes, kind of joining together, making a bunch of fans. He's got a lot of alluvial fans from all these intermittent and ephemeral tributaries coming in, and so those are shown in maroon. There are occasional places here, so where the valley margin is bedrock. He's also got some colluvial fans, so these are going to be steeper and angular material coming in as opposed to things delivered by water. So colluvium versus alluvium. And so by simply mapping those out, and then he's also got hill slope talus across some of these, and then some debris fans. Then what you can imagine is that all these different fans have very different caliber of sediment and very different type of sediment, angular versus subangular versus rounded, well sorted in the case of alluvial fans versus poorly sorted in the case of debris fans, versus being up against bedrock. And so then if you look at the channel through here and what it's up against, what's causing the confinement, you get a lot more insights in terms of sediment availability and how that's going to play out in terms of influencing the character of these reaches. And so this is kind of one of the very simple things that you can do with this, but it really provides a lot of insight. So what he's got mapped here is the reach types are these colors right here. So we've got in red a few confined valleys where greater than 90% of the channel length is up against a confining margin. And then in the blue, purple, dark blue, and lighter blue, these are partly confined valley types. And so you can see that some of these have their own wiggles, in between, and then others are really just kind of bouncing from valley margin to valley margin. What this map shows, though, is the proportion for each of these reaches. So here's this purple, which represents, in this case, this partly confined, low sinuosity, margin controlled gravel bed stream. Okay, these are those valley geomorphic units that we talked about. So we've got the valley bottom, the floodplain, but then what is the confining margin? Okay, and this is showing the proportions of this. So of this 7.5 kilometer reach, it's partly confined, so that's between 10 and 90%. So 50% of it, i.e. 3.4 kilometers of it, is up against a confining margin. And this is just showing, well, what is it? So about 1 kilometer of it is up against bedrock. About 1 kilometer of it's up against alluvial fans. About 0.71 kilometers is up against colluvium, and another 0.44 up against colluvial fans. And so the sediment supply from these things feeding itself along those confining margins is going to be very, very different across those. You can play that same game for these different things. Now, not surprisingly, the confined units, right? So these confined reaches, well, that's 7.3 kilometers, and it's got more confinement, 5.2, and most of it in that case is bedrock. So that's kind of interesting. And so there's just these give us further insight into not only the degree of adjustment that's possible, but the type of sediment that's available, and therefore the behavior of these sorts of reaches. This is all just a simple mapping exercise, and but it gives us a lot of insight into the sort of geomorphology of these systems. Now, ultimately, it also gives us some insight into the ecohydraulics. This is an area where we're focused on the 3 species of suckers and in these desert rivers down here. And one of the things that's been sort of impacted in some of these reaches has been some of the quality of fish habitat. And a lot of the better habitat is created where we have less invasive vegetation, more access to some of this sediment to produce big bars, and have more diverse in-stream geomorphic units. And so the point of this is just that some of these simple additions in terms of a little bit more detail in this flexible river styles framework can allow us to get more insights into some of the things that ultimately control ecohydraulics and matter from a sort of fisheries management perspective. Okay, so we're going to leave that there, and the last thing the next video we'll do is talk about the homework.